we're going to do is create another query. I'm just going to save it. Again, there are query wizards, but I'm going to teach you using the query design from scratch because I think the wizards will just be a useful tool that we'll talk about later. So we're going to create a query that we're going to save. Hold on, I got to stop the transcripts. I don't want transcripts. I don't know why it's doing that. Okay, what we're going to do is create a few queries today, if we can get to them, to set up for in the future. In the next, if we can get through these, we're going to start building data entry forms, very simple data entry forms for a survey, and also for if you have personnel that are going to enter age measurements. I'm going to show you how to create a couple simple forms. But part of the forms is creating queries that filters the data and helps with that. So we're going to create a query called years, and what it's going to do is create an inventory of the number of years in your data set. So if you have a station that has, whatever, 30, 40 years of data, it's nice to have a list of years that exist in your data, and that's what we're going to do right now. So we're going to go ahead and grab the card one table. So there's a few ways to do it. Again, you can add tables from the table box here. We're going to do that, or you could have just done it this way. But we'll just leave this in the queries. So what we're going to do is grab the date field, right? So there's only 4 dates. And what we're going to do is create a field where we're going to just inventory unique values of years. So if you recall from the last time, we're going to create it. We're going to assign this field as a year. So we're going to type in year and then use the colon as a separator. So to the left of that is the name of that field. Sometimes you have to be really careful if you use the same name as a true data field name. It could get confusing. So there are no year fields in anything. And this is the most important function. So we're going to create a function called year. And then we use parentheses. And again, the field that you are extracting. So what we're going to do is extract the year from the date. So date is a field in the database in the card one, and dates should have square brackets around it. And I just messed that up. And then close the parentheses. So what we're going to do, what we did is create a field that extracts the year from the date. So if you run it, you should see only 4 years of data in our data set, or actually 3, right? So we have 2 repeating. So these aren't unique values. So the way to do that is to hit the totals. And when you have a group by, it creates unique values by that field. All right, everybody there? So then we're going to save this, and you can either file save as, or if you create a new query, it'll just ask you to save it. So we're going to do, and as I mentioned, it is helpful to use people that do heavy developing in databases, and I think it's important to start thinking about doing that because you can access information and you have all these names and it's sorted right. So it is a good practice to create the type right now. So for queries, we do QRY, and then I'm going to put years, and then hit OK. So it renames this query as years, and basically it's an inventory of years. So again, if you recall, we had 2 1993s, I think. And if you, again, look at the design view, we're grouping by, so it's creating a grouping by year. And then you can create groupings that are stratified too. So let's say year by station, then it's going to expand a little bit, right? Because when you group by, it creates unique output by the number of fields. So even though there's 3 unique years, there's 4 unique combinations of year and station. Hopefully that made sense. So we're going to go back to design, and I'm going to get rid of station because all we wanted to do, I wanted to show you is how to create a group by. So just delete that of the number of years. So when you develop a form, you create drop lists like you typically see in most things on the internet. The drop list will have a unique inventory of the years as opposed to if you didn't have group by and you had the totals off and then you did this drop list in the forms, you would have 2 records of 1993 on that list, which would be confusing. Again, we'll hit the totals, run it, and it creates that. So what we're doing is setting up something for the form, but it's the important thing is to show you how to use years. And I'm going to show you more about the totals function in that we can do basic computations and summaries of the data. So a select query evolves to something more complex from just selecting data, in that when you use the totals button, you start creating summaries and groupings. All right, hopefully that was understandable. All right, so I am creating a list of functions that I think you'll use more. There's probably thousands and thousands of functions. I'm only going to show you the key ones that you end up using most of the time. So if you have something you want to do and manipulate with the data or a value, you can look up different functions that do things. If you want to look at, for example, a date, if you want to look at the decimal value of that, you can extract that. But I don't know who does that. Or if you want to look at, for example, if you have a date and you want the Julian date, there is a function to do that. I'll list that for you. That basically, a Julian date basically numbers the year from 1 to 365. Usually that's with temperature and stuff like that. So the next thing I want to show you, we did the is to make, what we're going to do is use the next query type. All right, so again, go to create and query. So we're working through the queries. The select query has two modes. It's the basic extraction of data, then you do summarization with the totals. What I want to show you now is a make table query. All right, so what we're going to do is create a table. So this is going to step back to normalization. So let's look at the tables we have, and let's look at the fish data quickly. So there are some violations of normalization that I've let go so far because of the time it takes, but we're going to use our normalization rules we learned to move the age data to an age table. So in your programs, you are going to have the potential for multiple ages for each fish, and that is not possible with the way this is structured. So fish ID 1 cannot be repeating because it has to be a primary key. You don't want to have redundant data. So according to this, right now they only have 1 age, but if you had a second age, for example, 0 is scale and 1 is otolith. Let's say this fish, you extracted both structures, where would you put that other age? So the not appropriate thing to do is age 1, age 2, age 3, and age 4. And we talked about this a little bit, and you're going to see that still to this day when you go out and work. So the way to do that is to normalize this and put it in an age table. And we're going to do that formally we're going to normalize it by creating a make table query. So let's go. So you have a query, I'll open up a new query. So again, create query. And then under query design, we're going to do a make table. All right. So now when you create a make table, it's going to ask you what the name is. So we're going to do, let's see, C3 age. We could just leave it C3 age or age data. It's up to you guys. I guess I'll do data. I need to be more consistent between my workshops because my videos probably are a little different that I have because some of them I forget to put the age. So we're going to create a table called C3 age data. So if you forgot what that is, go back to the make table. What we're doing is specifying what we're going to create the table, and we haven't done it yet. So it's C3 age data in the current database. You can actually do some manipulations and create a table in a separate database, and we'll talk about that. We're not going to do that today. So we're doing that. And what we're going to do is drag the card3 data, and we're going to move the age data to the age table. So I'm going to ask one of you guys, which fields do you think we need to put in the age table? So obviously age and age structure, right? We don't want that in the card 3 anymore because that age assignment that we saw in that table, so you can actually look at that, this age and the structure that it was assessed for, we want to put in the other table. So in this case, this fish number 2 never had an age measured, but the age structure was collected, which was a scale. Does that make sense? So let's go back to the query. Are you guys lost? So we want to extract the age and age structure from the fish table and put it in an age table. But what else do you need here so you know which fish it is?
Fish ID?
Yeah. So that would be, so right now we are creating a make table query. And we basically have fish ID, age, and age structure that we want to export. So one thing you have to be careful about on your up here, I want you to think about these. Anything with an exclamation point. In database developers, they call that a bang, which I don't think, which is weird. I don't know. It might not be used anymore, but anything with exclamation point is what's called an action query. So if you run this, it's going to do an action. It's going to give you a warning. And I'm going to say no because we don't want to do it. And once you do it, if you click it twice, it'll do it twice. So you have to be very careful with the queries that are action queries. And you don't want to make a million tables, overwrite them. You don't want to keep appending data. So let's say we're going to do an append next. Append means to add data to an existing table. If you keep clicking this, it's going to keep adding it, and it'll allow it unless it violates a key, some kind of key thing. So you have to be really careful. Update is to change existing values, and then delete is to delete a record. So these action queries, you have to be really careful. So if you're messing around and doing an action query, like we're going to make a table, you can first look at it under view. So this is what it's going to look like that you're going to make the table. So one thing I want to point out is we don't want the age table to have records with no age information like this. So this age structure is what was collected, but also for this fish, it's the age structure that had an age measurement. So we don't want these records in the age table. I mean, why have a table of a bunch of blank values? I mean, we don't even know, like, we don't know its zodiac sign either, and I don't want to have a zodiac field with a whole bunch of nulls. So what we want to do is create a criteria of only fish data, right? Fish age data. So if you put not null and run, and then don't run it, look at it. So now, see this right here? This is an old convention of coding. That's there was no, the oldest lake trout is 62 years old. We just measured that last year. So this is one of those things that is a legacy from the old. We're not going to mess with that right now. I just noticed that there are no lake trout 99 years old. So what it's done now with the criteria is that it only extracts records with ages and age structures that we want to put in the make table. So go back to design view. So now we are ready to create that table. So again, we are extracting data from card 3 fish data, and these fields are what we're going to extract, and we're only going to take records with actually age measurements. And again, if you click on make table, it's putting it in a C3 age data table. So when you're ready, go ahead and run it. It's going to say, are you sure? So there's 40 age measurements, even though there are more fish records in the card 3. So I'm not going to mess with this right now. I want to show you. I'm going to hit no. If you go to card 3 table, these record indices down here tell you how many totals there are. So there's 68 fish. The cursor's on record 2. That's all that is. So again, I'm going to go ahead and run this make table query. So from the card 3 fish data, I'm going to normalize it by moving the age data for ones that have measurements to a make table. So I'm going to run it, and it's there. one of the nice things about creating a table this way is that the fish ID, it's pulling the data type there. Whereas as you recall, when we import data, someone else or some other table this might be a double precision value, and then your data table's integer. In this way, it appended it. So you can go over, see how to create age data. So all your age data are there now. All right. So that's how you manipulate and move around data in creating tables. So what I'm going to show you is next, we don't need those age data in the card 3 table, right? So I'm going to close. So when you have an action query, so this was a make table query, and we close it, and I'm just going to leave it named as query 3. And if you go to queries, this is an important thing for you to really think about. See how there's an exclamation point here? On mine, it's hard to see. If you have a white background, it should show up. Anything with an action query, if you double click that, it's going to execute it. That's why every time you have a query, unless you know what it's doing, be careful. Always open a query by design view. It's especially the ones with exclamation points, because you don't know what the criteria are. If you double click that, it'll run it again. So I'm gonna do it, see if I can mess this up. So what that's saying is it's gonna run a make table query with whatever's in there. And if this is weeks later, I don't remember what I did, it's gonna modify your table because that table already exists. So we're gonna hit no and design. So again, an action query, the way to put it on safe, put the safety on, is convert it to a select query and hit. So now it's just a select query. Hopefully that made sense. Go back to design view. Now if I went back to, like, I'm ready to make table, it's going to start from scratch. So as a practice, I try not to leave any action queries active. I always put it on safety by putting it to select query or get rid of them. So that's dangerous. So I'm going to close query 3. So what we're going to do now is get rid of this here. In fact, I'm just going to get rid of age because we want the age structure that was collected in this table too. I think it's useful to know what age structures were collected. And then in the card 3 age table, every age measurement should have an age structure associated with it, so we know what the age was measured from. So what we'll do is go to design view and go get rid of age. So you can click on that and delete. And if you go back, this is how you can normalize and clean up your data tables. So that got rid of it. Hopefully that made sense. All right. And let's see. So what we're going to do is create one more query. So notice, you know how we create a query of years? We're going to create another one to set up for an entry form for age entries later on. So I want you to create a new query where we're going to pull in the card 1, the card 3, so again, notice that when we pull in card 1 and card 3, it automatically knows the foundational relationship between those tables. If you recall, we created the foundational relationships. It doesn't have to be done, but it should be done for your core tables and code tables, which I don't think I've done with everything yet. Maybe I'll make that your homework assignment. So with this new age table, we did not create a foundational relationship, so it automatically tries to link keys. So again, this is a primary key, right? The fish ID is unique in the fish table. And here is a foreign key in that this fish number 1, can have 1 to infinite number of age measurements. So this is the foreign key, and that's not a unique key. So what we're going to do in this one is we're going to create kind of an age entry table. So what we're going to do is basically take the date, the species, And then we're going to do fish ID, age, and age structure. What we have to do also is fix this relationship. Right now it's a one-to-one. We want to create this as a one-to-many. So what we want to do is set that. Include all records from fish data and those that are related here. So it's a one-to-many. I'm going to click on that again so that made sense. So right now it has date, species, fish ID, age, and field. So if you just run it, again, it's a select query right now. It's going to have everything with nulls. So what we want to do is create this so that it only shows fish with age structures and ages. So what we're going to do is just say not null for age. We also want the year, not just the date. So let's go ahead and convert that to create a year field. So I basically created a year field, species, the fish ID, age, and age structure. And we want only the records with ages. So if you run this, it basically has all the fish that have age records with age structures. All right, so what we're going to do is save this for later use. And we're going to do QRY. Now, when I create queries that are set up for entry forms, I always basically name them entry. So that way, when your queries are, when you have millions of them here, they're organized by the name. So there are some tricks to this rather than looking through and figuring out where the hell they are and what they are. I always create entry forms with entry, and then this one is, we're going to just put age, or you can capitalize it. It's not too case sensitive in access. R is explicitly case sensitive, which is a pain in the ass. But in access, it's not. So what we did is create an age entry. And again, it extracts all the records of fish that have age measurements. This is for future filtering if you want to look up or correct ages, and we'll talk about that later. Any questions? All right. So what I'm going to show you next are an append and a delete query. So the Klingon DNR was helping out with some surveys, and they have some data. So there is a file I gave you guys either on Google Drive or actually on the email. That's a Klingon DNR card 1. So what we're going to do is import that first. So again, external data, new data source, and we're actually going to bring it from an Excel file. And under the class files, there should be one called Klingon DNR card 1 data. So what we're going to do is bring in the data that they conducted the survey with. Hit OK. So when you're working with old data sets or working with other agencies or multiple computers for your surveys, you're going to be doing this importing data. So again, it walks you through the import wizard. It has lift, date, and station. So when you're working with other agencies or old data, the field names could be different. So ours is called ID number or operational ID. So it's essentially the same, but the terminology was a bit different. So we're going to hit next. It's going to, again, walk you through. With very few exceptions, we always set no primary key and hit next. And then you can bring it in as sheet 1, or we can just do Klingon. So here's a trick I'm going to show you. So when you name things, this is usually alphabetical. If you have thousands of things here and you're trying to dig through K, wherever the hell that is down here, one way to throw things to the top is to use numbers or some sort of index that'll bring it to the top. So if you have a lot of stuff here, and this is going to be temporary anyway, it's nice to have stuff clustered above your core stuff that you really want. So that's kind of a trick I use. And one thing in programming and coding that is a habit you have to get out of is using spaces. It is really bad practice to use spaces because sometimes it's hard to see them depending on the font and the font size. And so using underscore always is a good separator. So you see we imported the Klingon DNR data and it shot it to the top, and it's actually a card one. So you can see these are the records. So what we're going to do, our job today is to bring their data into our card one. So in this case, we didn't get any card 3 bio data. So they didn't catch any fish, or they don't know what the hell they're doing. In fact, they don't even have gear. And then we're going to decide to delete the records. So I'm going to show you how to import data and also delete records formally through queries. So we can close that. So now we're going to create a query. When you create a query, it'll automatically go to the query design menu. And what we're going to do is append that. And what we're going to do, again, these are action queries, so you got to be really careful what you're doing and explicit. So when you're appending, it has to have an existing table. And what we're going to do is append to card 1 bio data. And hit OK. And what we're going to do is, so you could do it that way, or you can bring it over this way. So one of the things, you'll see this every time in a query, the star means all records. So it doesn't list them individually. That's okay to do sometimes. I don't think that's a good idea, and it won't work because the names of the fields don't match to what our card 1 is. So if you look at card 1, our field names are ID number, date, and station. So ID number is different, even though it means the same thing. So another way to do it, which I encourage you to do, is to do it one field at a time. So for example, if the Klingon DNR had some other attribute here we don't want, that's useless, you don't have to select it. But if you hit the star, the asterisk, it's going to bring everything. So this way is more explicit in what you're doing in your query. So always be explicit, because this is essentially a visual way to write code. So notice when we click that, the lift, it doesn't know. So it tries to match the field name. So for example, if their station number is not what we use for station, it'll automatically match it. You can force it to a different field by here. But their station code is the same thing, so the same meaning. So again, reading your QBE grid, the fields from the Klingon table are at the top, right? So the field names are here. It's from Klingon table. We're going to append to which fields in our database, which was specified here. Just like make table, the specification table is here. It doesn't display it here for some reason. It should, I guess. But we're appending to our card 1, but there's no field that lift goes to. Instead of renaming this in the Klingon table, you can just force it to go to ID number. So we're bringing their lift, which is our ID number, their date and station, and we're going to append it to our card 1. And again, you can view it before squeezing the trigger. So again, the run, this exclamation, the bang is a trigger to execute. So now we're going to execute this. It's going to ask you, they only collected one observation. So again, databases are very explicit. So this is telling you there's a validation rule violation. All right. So that means it's not allowing you. So that's why this is important and useful to do. It allows cleanup and removes errors. So let's figure out what's going on. So it has lift 1002. So one thing that could happen is you can't have a second lift that's 1002. And it's not there. So that's not the issue. It's a date and station. So there's something that's invalid and it can't import it. Is it the format of their data? So if we look at lift ID, it's a double value. And if we look at ours again, it's in long integer. So it's not allowing that. And the other thing to check is if you have other required fields and it doesn't have it, then it's, it could give you an error in that there's a required data field that you're not appending. So what we're going to do, we're going to go back to the Klingon table and change this to a long integer to match. And it's going to ask you to save it. And yes. So now we're going to try to execute this query. Again, so that's not the issue, right? So the data, that would be a type conversion. We want to make sure the integer, so there's a validation rule violation. So what we have to check, there's something invalid. So another thing it could be is if you have station code in your abiotic table linked to a code table and station 40 is not listed, it won't let you append it because it's an invalid station code. We haven't established that relationship yet, and that's going to be your homework assignment. It's to create a station code so that only station codes that are in existence in our code table can be appended and put in the database. This is how you restrict wrong entries in the data set. So right now we don't have that established. So that's not the issue. I think the issue is these other things, there might be required. So the other validation is look at requirements. Stations required, so depth is required. So that's one of the issues. So if we delete the requirement for depths, this is just to show you an example. I must have clicked something wrong. Oh, okay. There we go. So what it is, it's requiring depth. I must have messed something up here. Let me close it. Mention here. And get rid of this validation rule. And then I'm going to set it to null. There we go. So this, that depth one was required. So again, you have to look through if there's a required field, it's not going to allow that entry. So we're requiring station, project code's not required, date's not even required. So if you have a required field, then it's not going to allow that. All right, let's give this another try. So this is what happens when you're dealing with old data or importing data. There's a lot of cleanup and it's very explicit, but this is a really good learning about learning what's going on with your data and not letting crappy data in. So see it work now. It's because it required a depth and we didn't have that. That makes sense? It seems like a lot of pain in the ass, but it's really important because when you deal with large volumes of data and you want your data stored right, or you want to bring in data correctly, these explicit things are important because it'll catch you down the road when you say like, well, yeah, depth's required. Oh no, there are a whole bunch of depths that aren't in there. So we released the rule on that to get that in there. All right, so now click on card one, and we brought in that Klingon data. We would not normally allow these nulls, and we're just leaving this as an example. So we imported the Klingon data. So now let's say we decide we really don't want it because it's not really, it was a crappy survey. So what we can do, I'm going to start from scratch. I'm going to not save that. We're going to create a new query, and we're going to do a delete query. And what do we want delete? We're going to delete, basically, this is one case where you'll use the star we're going to delete the Klingon data. So we want to delete everything that was imported. And then we have to know what the identifier is for that. So in this case, a realistic database is you would have a collector. In this case, it's a license. So what we have to do is figure out what makes this unique. So we could just do ID number 1002. But typically, if you import data, you're going to know the agency, which would have a code here. So we could have a Klingon code or something like that. But in this case, we're just going to delete that record. We know that lift ID 1002 is crap and we want to get rid of it. So in this case, we're going to delete all the records by starring it, and then where it is 1002 in the criteria. Oh. All right. So what this is saying in a delete query, we're deleting right here. Again, if we hit this button, we're deleting from card 1 all of the record, all of the fields. We're deleting the whole record where lift ID is 1002. So when you run it, it's going to give you a warning. You're about to delete one row from the specified table, and hit yes. And then if you click on that, we deleted it. So what we did is we did an append query to import data, append to an existing table. And what we did is a query, an action query to delete a record. You have to be really careful doing this. And it requires an explicit set of criteria. So that's how you delete a record or a set of records. So let's say we had thousands of records from an agency, like we had license where, their license number was 12. It could do a huge deletion. And again, if you recall to our relationships, it could also do cascade deletes. So if we had a linkage between card 1 and card 3, which we do as a foundation relationship. So if there was 1,000 lifts by the Klingons, when we do this with the card 1, it'll cascade delete all of the other records, which is what we want. So if we had a bunch of fish data and age data and we want to purge that, it would cascade delete it. And you don't have to do the relationships here because by default, your base core relationships in the database has that established relationship already. If you recall, right there, cascade delete, that relationship is set at the core so that when we do this, if there was all related records in the database, all the Klingon data would be purged. I wouldn't do that because I'm very accepting of them. Hopefully that was useful. All right. I think what we're going to end in the last bit is we're going to do a cross-tabulation query. This, again, is a very useful computational query. So we did an update. We got rid of that. Oh, okay. I'm sorry. I'm losing track. So what we did is we did a make table, we did an append, then we did a delete. I want to do a quick update query. So what I want you to do, an update again means you're going to change the value. So your database we should be doing stuff in metric. So if you recall, the length are in inches. So we're going to do an update. We're going to update that and change the value to metric. So open up a new query, drag the fish data table, and grab the length field. So right now it's a select query, so not an action query. We're not updating. So I just want to run a selection. So what we're doing is updating those values of length to metric. So when you click the update, it's going to take the existing field and it's going to ask you, what do you want to update it to? So what we're going to update it to is length times 25.4. Is that right? Yeah. Each inch is 25.4 millimeters. So what we're doing is for lengths, we're going to take the existing length and multiply it by 25.4 to convert it to millimeters. And again, before this action, before you squeeze the trigger, you can take a view. It's just going to display what field you have. It's going to do the computation until you execute it. So go ahead and run it. It's going to say, I'm going to update 68 records. And when you hit OK, it does it. It doesn't give you another thing like it's done and here's what it looks like. So that's why if you like, did it do it? And if you click this again, it's going to take the metric length right now and again multiply it by 25.4. So I don't even know what units those are. So you have to be very careful and put it on safety. Now run the query looking at length from the table. Now it's in metric. That makes sense? We could run this again. It'll multiply. So if I ran that again, it would take 480.06 and multiply it by 25.4 again. So you have to be really careful and not be like an old person clicking on stuff all like 20 times. All right, we're going to quickly. So that's how you update. And again, I'm going to close this and not save it because I don't want an action query saved. So now we're going to create a cross tabulation query. Oh, is that a question? Or are you? Okay. So what we're going to do is a crosstab query. And what we're going to do is do a simple length frequency of our data. So basically, we're going to grab the card3 fish data, and we're going to count how many fish there are by length. And we actually can do it by species. So let's grab species, length. And the way I count fish in a database is I count the keys because each of these it's like their social security numbers. So if I count this, that means I know they're unique records of fish. I can count the lengths, but if you have a fish without a length, which actually shouldn't happen, or if you count like the sex, if there's a null value, it won't count that. So you want to count something that makes it unique in existence as an individual. So we extracted those three fields. It's just a display of what we have. Now we're going to do a cross tabulation, but first we're going to go to totals and then cross tab. So when a cross tab, which is similar to a pivot table in Excel, if you use that, is that it does cross tabulation. So you're going to have a summarization by factors by row on the left and across the top as another factor. Now, one thing that's different in the Access than Excel is that you can only have one column factor or variable that it's doing the computation. So we're going to put rows for the species, and we're going to look at a computation of, actually, I changed my mind. Let's do species across the column, and then we're going to do rows for the length, and then we're going to count. So this is, again, a total, so you have all these type of computations. We're going to look at count, and then you have to specify what this is, and it's actually the value. So right now, what this is saying is going to cross tabulation of species across the columns of length down the rows, and it's count how many fish by length by species. Now this is individual length, so it's every millimeter. So if we run this, it's going to be crazy kind of computation. So across the top are the two species. This is lean and Siskiwet lake trout. For lengths, these are all the individual lengths. That's not how you typically want to do length frequencies. You want to bin them. So I'm going to show you, before we leave, a really important function called partition. And we're going to create length bins. And again, you're going to find this very useful. So if we just wanted to bin this by 100 millimeter length bins, you could just take the integer value of length or something, right? Basically by 100. If you divided by 100 and took the integer, it'd be every 100 millimeters, but that's kind of too much math here. So what I'm going to show you is length bin. So you can do LB colon, the function is called partition, P-A-R-T-I-T-I-O-N, and then parentheses. And again, we're going to do partition of length. So you put length in square brackets, around it. And we're going to go from 0 millimeters to like 1200, which is the largest, around the largest we see. And then you're going to put commas in between. So what it's saying is we're going to do a field called length bin. We're going to partition length from 0 to 1200 millimeters. So that's the range of values that you want to partition. And then what do you want to partition and bin them by? So let's do it by 100 millimeters. And then close the parentheses. So what this is saying is it's counting the number of fish by length bin in 100 millimeter length bins for each species. If you run it, what it did is for so it'll know, you know, what the sizes are. So in our data set, from 200 to 299 millimeters is one lean lake trout, and there's no Siskoet. So this is cross tabulation. Does that make sense? So we can go back. Let's say you want to do it by 50 millimeters.
And Sean, is there a way to show nulls? Like if there was a length bin where there's nothing, can you make it still show that length bin?
There is. So what I'm going to do is spend more time next time to talk about how you force zeros for nulls, right? So databases are logical in that if something doesn't exist, how does it know what the zero is? You know what I mean? Like, for example, so I'm going to get into that next time. Yes, there is a way to do that. Basically what you do is we'll do another function next time called if statements. And basically, if null, will assign 0. And that's what we would do in our computations. I think in business, they don't really do that kind of stuff. You know, like if they didn't have a sale, who cares? You know, there was $0. For us, it matters. Does that make sense? I don't want to get into the weeds of that. I will show you how to force zeros in here. So this is a simple cross tab. Partition function is really useful. I think we just change it to 50 millimeters. And one last thing I'll tell you. So let's say you only want to partition a certain size range and anything outside you want to lump them. Then you could do this so that it's like 500 millimeters to 600 millimeters. I only want to look at fish between 500 600 millimeters, and I want to look at it in detail by, let's say, 10 millimeters. So if we read this, we're partitioning length for fish between 500 600 millimeters by 10 millimeters. Now what it does is it creates groupings for anything outside of that. So you have your fine resolution data. These are all by 10 millimeters as we told it to. Everything outside of that is just going to lump less than 500 and then greater than 600. Did that make sense? So this is how in Access you would create uneven groupings of bins. Does that make sense? Like, for example, if you just care about this stuff and whatever, you know, we never see this. Usually is the case when you're dealing with data with large fish. Normally, you know, you're going to have every millimeter length, there'll be some frequency. Like with lake trout, once you get to 700 millimeters, some years or data sets, there'll be fish. So you might as well lump them from 600 and larger. You know, like for diet, we tend to do that. So this might have been a lot. It's being recorded. I am going to set out a list of functions, but this is one of the most important ones as a tool for you guys. And what I'm going to urge you guys to do is go back and refresh what we did today and play around with the data and manipulate it and ask different questions. Like, for example, this is just a count of it, but if we put a measurement here, you can start averaging. So we'll talk about some basic summaries from cross tabs in that we can start looking at averages, standard deviation, or if you want to add things, all of these things are here available. And again, all of this you can do in R, right? But a lot of it you can do here in Access. All right, I'm going to stop with new information and just be here to answer questions because the next step is I'm going to show you a query chain on how to calculate catch per unit effort and deal with nulls of 0 catches because I think that'll take some time to do that. And then I think after that, I'll probably show you guys how to do some basic data entry forms. I mean, this is a really simple data set. You guys have probably seen a lot more heavy volume data, but knowing the basic steps here can help you visualize this with, this is only so many fish, but you could see this with billions of fish. You can look at this by year, right? You can add complexity. So let's say you want to look at the length frequency by year. How would we do that? Just quickly. There's no information on what year these were caught, right? So again, you would bring this in, and then you could just bring in the date. So let's say I want to look at the length frequency by each sampling event. So as you add more fields, again, you can only do one column. So if we did it by row, for each day of sampling, this is the length frequency. So notice how this repeats. It repeats because it has to partition by the different sizes of fish on that date. So if you want to look at it annually, right, by year, you could just basically throw the year function in here. Which is probably the most utilized. Oh, I messed up. And close it. That makes sense? Notice how it said expression one? It's because I created a field and I didn't name it. I just did the function. So if you just do a function here, it'll just put expression one, expression two. The other place to look at this now, just quickly, if you look at the builder, it's like has a little wizard thing. So this is what you wrote for the function. So if you want to access all the functions in Access, there's a bunch of built-in functions for arrays, database, date and time, and then you can learn all the different functions. So what we did is year, which is a date and time function. I just knew the syntax for that, right? That. But let's say you want the month or day or something or hour serial value. So there's all kinds of things. There's mathematic, right? So there's a whole bunch of functions. You can do the cosine if we want to do cosine of length, which would be really fun, I guess. I don't know why. You could do all of these functions. So just remember, these are the shortcuts, the ones I'm showing you. But if you ever want to look up a function, build a function, you can access the different functions here and look at different things. And if you have a function you want to do, just Google it. So, and just say Microsoft Access, it'll tell you what it is, and then you can find it in here or write it in.
I had a question. Does the order of the columns matter?
So in this case, there's only one column, so it doesn't matter. But the rows, it does. It's higher. It's sequential by here, or you can force sorting, right? So by default, it sorts from left to right.
Okay.
And then it also displays that way, right? So I don't know what that means. I guess for this size, you can look at range. So you could do that. The other way to do it is and then you can also sort. So this places it, right? And then you could do descending.
So it's not just a display thing, though. It's actually affecting the way.
It is. Yep.
Oh, okay.
It's the output will be displayed from left to right, but you can also mess with it, and then you can also have you can have fields that are there but you don't show them, like in a standard query. And so these are ways to sort things. I don't know if that made sense. But yeah, it's systematically done. And then, so again, if you're already messing in R, this is just the DPLY, like their language is data manipulation. So I like to do most of it in Access because I can visualize and see the data. And as we work with query change, you can start seeing, like the steps to get the final answer. I don't know if that made sense. So we're going to calculate catch per effort from these data set, which is probably the most common thing you'll do in fisheries. And it's like relative abundance. And it's not just fisheries, but it's just the abundance standardized by the sampling gear and the effort used.
And then I think you might have answered but that third column with the like greater than, yeah, what's that?
So that is probably for a species. That might be a record that has no species. Let's see, was that there
Mm.
before?
I don't know.
So what this is, it's a column. So there's a null field of a species. So let's see if that was allowed. I guess I didn't notice that. That's not possible. So, all right, let me think about what that is. So a lot of times when this comes out, it'll be a field that doesn't have an assignment, and
Mhm.
there's no referential integrity requiring that. That's kind of a weird thing. Was that there before? Let's see, not sorted. But typically when you have it's basically a null value of the column variable.
Mhm.
I'm just trying to see if we have a record with a null field. It might be a species thing or a length. That's a good question. When you have something like that, you should invest. But what typically happens in a cross tabulation, it'll pull out something that is a null, where there's no basically nothing is met for all the field variables. Does that make sense?
Mhm.
All right. So that's an example of a crosstab that is very useful to summarize stuff. So you could do like average length or something by whatever strata. So you typically do this in Excel, but you could do this in Access pretty simply. And I guess you can add the complexity. So let's say you want to change the species to a name, you basically would add that, right? And then you can display the name instead. So again, you have to do this, and you could do that as the column and get rid of that. So lake trout, Siskoa, that's lean. That makes sense?
Yep.
Okay. Hopefully that's not too much. I'm going to stop the recording now. I have to trim it because I don't